I'll tell a quick short story here while he's getting himself set up on this. The Zarf t-shirt is one of my few t-shirts that I don't wear in public too much. Usually it's a sleeping shirt or something like that, or an exercise shirt. But coming back from the eclipse, I had just been camping. I wasn't thinking too much, threw it on, and a bunch of kids saw me, and they're like, "That must be a new Pokemon. We want to get a shirt of that thing." So
nice.
They were so
I
impressed.
did bring some shirts, by the way. So find me afterwards. I'll give you some shirts.
If you want kids to think you got the latest and greatest Pokemon, that's the shirt to have. All right, Austin, take it away, chatting about Zarf.
Thank you very much. Mic working well? Sweet. Pumped to be speaking here. Welcome my talk, Bridging the Air Gap, Simplified Disconnected Kubernetes Deployments with Zarf. I am a software engineer. I'm a full-time Zarf maintainer over at Defense Unicorns. They originally created Zarf, Apache 2 license. We wanted to make sure it's free software forever, so we donated it to the OpenSSF, or Open Source Security Foundation. It's under the Linux Foundation, and it kind of guarantees, hey, no one can rug pull this, right? But want to start at the beginning. What is an air gap? Essentially, it's an environment without internet access, sometimes fully disconnected, sometimes semi-disconnected. So you might think of a submarine. It can go up to the surface and connect to the internet, but when it's at the bottom of the ocean, obviously, there's not going to be an internet connection there. Or a rocket ship, when it's on land, internet when it's in space. Maybe it has internet, maybe not. And then, some other environments have to make sure they do have internet in case something goes wrong, like you're in a nuclear power plant, and so functionally you might want to design your system like you're in an air gap. And so an air gap is going to be very secure, but it can be very complicated to operate in. So kind of a saying I heard is, the most secure system is locked in a safe at the bottom of the ocean, but that's very hard to use, right? The UX is horrible. So a question you might ask yourself, how do I get the security of an air gap, but the UX of a cloud native app? Because the air gap is not easy, there's a lot of challenges, dependency hell. You might not know which app your dependencies have, which dependencies you have on your app until you actually bring it into the air gap. Your app might reach out to Google for its fonts. Your Kubernetes cluster might have an operator that mutates the images to something else, and okay, now I'm in the air gap, I don't have the images I need. And then once you actually run into one of those errors, you don't have Stack Overflow, you don't have Google, you don't have ChatGPT. I think there were some other people talking about earlier bringing LLMs, and there's some good work with that, but you got to get the LLMs in there first, and so we do have to manage these problems. One of my coworkers who did work in the air gap said, I used to run into problems in the air gap, literally write down my error message on pen and paper, walk out, look up the error message on my phone, rewrite the answer down on pen and paper, hopefully I got it right, run back inside, hopefully I did it right? And so there's that, and then when we go to the Kubernetes specific solution, it's not really designed natively for the air gap, right? There's this chicken and egg problem we'll get into. There's not a container registry, and so you need a container registry to run Kubernetes, and you don't have one. How do you manage that? And kind of, again, want to harp on this point. It might work outside of the air gap. It works on my machine, works on my container, works on my cluster. Hey, it doesn't work here, and it's actually quite a costly mistake for something to not work in the air gap, right? Because you have to get this data into the air gap. Someone told me that the only way they can get data into their environment was from a helicopter. And so if you mess up your deployment there and you have to bring data in again, you're burning money. You have to do another helicopter ride. Another one of my coworkers told me that every time they brought data into their environment, they had to destroy the hard drives that they brought into the high side. And so, again, this is like losing money. I think he said they ran out of hard drives and tried to use floppy disks, but the software to put data on the floppy disks didn't do it right, didn't account for that, and so it took 24 hours to put in some negligible amount of data. Also, before I continue, out of curiosity, does anyone here work in the air gap? Or has worked in the air gap before? All right, pretty solid amount. We're in DC. A lot of times there's skiffs and whatnot. A lot of times there's systems where if you plug in this system to the internet, you go to jail. It's illegal. And so when we talk about a cluster, we have some common dependencies that you want to bring in. You have your K8s manifests and charts. These might need to be edited to point to your registry in the air gap. You have your Docker images. Again, you need to account for everything in the air gap. When we talk about managing dependencies, we want to make sure that we have the right version and we know which version we do need to bring in the air gap, and we want to track that. Ideally, we can track that with some sort of version control. You don't always need Git repositories, but often you will want your repos there, especially if you're running a Kubernetes cluster with something like Flux or Argo CD. And ideally, with a cloud-native app, you don't really have to run bash commands, or at least those will be in jobs. But that's not really always the case. And also, you need some process to actually stand up your cluster. And you want that to be repeatable. You want that to be easy for the person who's in the air gap. Someone who works in the air gap might not be the most technical, right? They might be someone in a submarine that wants to be much better at being a mechanic of a submarine than being a Kubernetes expert, right? And just to harp on this registry problem, you need a registry to run your Kubernetes cluster. You want to run your registry in the cluster because, there's the distribution v3 image, which is really convenient. But how do you actually, classic chicken and egg, maybe you could do a Docker run with some sort of registry container. But now are you running your production registry from Docker run? Do you even have Docker in your system? And so, yeah, classic chicken and egg. And so we get to what I'm going to talk about today. Zarf, I'm a full-time maintainer. It is free software, as I said. We like to call it the air gap native package manager for Kubernetes, kind of ripping on Helm's logo, the package manager, Helm's tagline, excuse me. The package manager for Kubernetes, we love Helm, we use it pretty extensively within Zarf. And so quick overview, it's like really our goal is to have identical deployments across connected and disconnected environments. We want to provide creators a way to have declarative package creation and create their package in a connected environment where they can test it, where they can do all of that technical overhead and make it easy for someone deploying. And just to harp on that point, you want a simulated air gap, and we'll kind of get into that in my demo where I'm just going to turn my Wi-Fi off. But you want those fast feedback loops. You want to be able to test everything on the connected side like it's in an air gap. So when you get there, you're not wasting a helicopter ride. And then the deployer might be the same person, but a lot of times it might be someone, running a submarine. It might be someone running a F1, not F1. What are the planes called? F-35, thank you. And you want that to be really easy for them. They want to focus on their job. They want working software. They want simple deploys, and they want their cluster to be cattle. Something goes wrong, you don't want to, in this case, treat your cluster as a pet. You want to tear it down, bring it up. And you want that to be simple and to be done everywhere. Maybe you have 100 air gap environments and you want an identical install across all of them. Quick water break for me. So this is kind of the special sauce of Zarf. We take those common air gap dependencies, K8s manifest, Docker, and OCI images, Git repositories, and we capture them in a single tar file. That way, when you're going into the air gap, you essentially need 3 binaries: Zarf, which is a Go statically compiled binary, your Zarf package, and then the Zarf init package, which we'll get into a little bit, which kind of starts up your cluster. But we want it to be a lot less to manage. We want it to be declarative so that your dependencies are version controlled, so that you know exactly what you brought in before, and you know exactly what you need to bring in the future. And so this is an example Zarf manifest. You'll see here, we have the chart that we're going to bring in, and that's going to be a Helm chart with your values files and whatnot. We have the images that our chart needs. In this case, it's very simple. It's a pod info chart. Shout out Stefan Prod for making Flux and making this example we can all use. And to that point, maybe you're deploying a Flux application that has its manifest pointing to a Git repository. Hey, okay, I need this Git repository in the air gap. Zarf is also going to pull that repo into the package. And then I know it's a requirement, I think, from the US government. I know those are constantly changing, but you need SBOMs, so Zarf's going to automatically build that into the package. We bake in Sift, which has a functionality to convert your SBOM into whatever format you need. And then you might not have anything to view. JSON is kind of ugly. We have some built-in HTML files to view and deploy into the actual package. And package distribution, allows us to, once we actually create that package, we can push it to existing container registries. ORAS is a really amazing project. The maintainers of it are killing it. They're doing an excellent job. The OCI spec is awesome. Helm uses it, Flux uses it, obviously Docker images use it. And so essentially a lot of people are gonna have OCI registries already. Packages can be pushed to these existing registries, pulled with existing auth systems. When you pull a package, we deduplicate the layers just like you would a Docker image. So if you already have a package in your cache and only one image changed, you only need to pull that one image, right? And now that like Zarf's gaining adoption, we see different companies, Defense Unicorns, what I work for, Radius Method, hopefully more, publishing their package for the community. The community can use them anywhere in their air gap. And we have built-in signing with cosign to validate like, hey, the people who made this package actually made it. So now we do want to kind of get into the sauce of it, initializing a Zarf cluster. So we have our init package, which I talked about, which you're going to need to bring in, and that's going to come with a built-in optional K3s cluster in case you don't want to do that, operation to figure out, hey, how do I get my cluster here? It can be quite complex. And we have a cluster agnostic registry bootstrapping process. I'm going to talk about that in a little bit, but that gets very cool. It's a very interesting solution to be able to spin up your registry, without a registry. And that's where we're going to put our images, right? And so no matter where you are using Zarf, if you're using the Zarf registry, all the images are going to go there, and the Zarf agent is going to mutate all the images to point to that registry. And so now your deployment is pretty contained. It's pretty identical. One really cool thing that I think is an actual use case is like, we got an email from the organizers of this event, hey, you probably can't pull large images for your demo. The Wi-Fi is not fast enough. If you use Zarf, all the images would be local. You could just already pull those down and push them up really fast. And yeah, that would work, right? And then once you push them up, your resources are going to be mutated to the Zarf registry. And so talking about how we actually solve this registry problem, this might kind of go over heads, but I just kind of want to show how you have to do things a bit silly in the air gap almost. So what we actually do is we take a pod from an existing image. We know any cluster that's running is going to have at least something in kube system. And we know that it's going to have a running pod. So we take the image from a pod, we match it up with a node, we create a new pod using that image, and then we have a custom Rust injector, which is like the smallest possible OCI registry. It's less than 1 megabyte. And so we run that, we like override the pod image, we run that as a command, which now has spun up a very simple OCI registry. We serve that over a node port service, and then we have other config maps in the cluster that this Rust injector puts together into an actual image. That injector now serves that image so that our long-living registry pod can grab the registry 3 image, and voila, now we've solved the chicken and egg. Now we have an actual registry in the cluster. That then does an upgrade to point to itself, essentially. And now we have a node port service that serves the registry that the rest of the cluster can use. We're in Kubernetes, we have HA, and whatnot. And then once we take our actual Zarf agent, usually we're going to deploy these YAML files with the Zarf package deploy. I'll show that in a bit. It's a mutating webhook. It's going to override any pods that get deployed to it to point to the Zarf registry, essentially. That way you don't have to change your pods for your air-gap environment. You build your package once, it works anywhere is the idea. And the Zarf registry can also be an external registry. Let's say in the air-gap you also have a registry already. You can change it to point to that. Similarly, if you have a Git server or you deployed the Zarf Git server, your Flux resources or Argo resources are going to be mutated to point to that Git server in the air-gap. So let's show it off. First thing I'm going to do is turn off my Wi-Fi so we know it's for real. And I'm going to use, so we bake in some tools into Zarf just so people don't have to bring in the binaries. So just to show, I do not have a cluster here. And I'm going to do Zarf package deploy. I've pre-built a package because I don't have internet. In the real world, you might bring this over in the sneaker net, right? Literally on a USB drive with your feet. And so I'm going to deploy this package, which is going to give me a K3D cluster. Use K3D just because it's a little bit simpler than K3s. And so essentially this is just running files and bash commands. Nothing really Kubernetes yet, but we need to have this kind of escape hatch so that people can install their clusters. And so now if I do, again, Zarf tools, kubectl, get pods, we see we have our pods in the cluster. And now I'm going to run zarf init, which is going to spin up that registry and spin up the agent like I was saying earlier. And I'm not going to deploy the Git server. And here we can take a look at the pods as they go. So right now we're adding those config maps to the cluster. Pretty soon we'll see some pods spin up. First the injector and then the registry. The registry image is going to be pointing to this injector. So we have a Docker registry running. Got a little bit of time here, maybe another 10 seconds or so. And now that that's done, we're going to push that agent image up to that registry. That way we can have the agent now in the cluster, and any future deployments will be mutated to point to the Zarf registry. And we'll have a fun deployment in a second. First, before our real fun deployment, I want to just kind of show off the SBOMs with a different package that just has a little bit more meat to it. So if you look at maybe the pod info package we have here, it installs Flux, it installs the different apps you might need, or whichever apps you have, right, with a couple different methods for installing the classic pod info example. So here I'm just going to run, I already have built the Zarf package. If I try to build it now, it'll fail without internet. And so I'm just going to run this inspect SBOM command, which is going to give me all these SBOMs. If I'm in the air gap, it's a convenient way to have them here. And if I copy this path, I have a little viewer, a little bit easier to read than the JSON. Cool, so now let's deploy something. I'm going to deploy this DOS games package, very simple package. It's got a deployment and a service and a Doom game. I'll just go ahead and confirm so it's not interactive. And boom. Now I can run there we go. Looks like I have about 2 minutes, so I'm joking. Yeah, I actually can't slideshow until I connect back to the internet. And yeah, any questions? And I do want to give the Zarf GitHub and docs links for anybody that's interested.
I see questions. I see multiple questions. Y'all ever try running across stage with a foot that's still asleep?
Really cool demonstration. With the SBOMs, are you also like scanning those SBOMs, or not scanning, but like evaluating the SBOMs against CVEs, and can, as part of that packaging of your Zarf archive, can you give it thresholds or boundaries or criteria for like, don't build this package or stop building this package if certain vulnerabilities exist, or like criticals or things like that?
So we don't do any of that. Sift will check for the SBOMs, at least that are available at the time. You could, in theory, put into your package, like with those actions I showed, that deploy something like a cluster, you could also have bash commands that maybe check the package for SBOMs above a certain threshold, assuming SIFT has some tools to do that. Or you can pack griped into your air gap environment, but we don't do anything like that natively.
Any other questions? Oh, you're going to make me run all the way over here. This is when the other people, if they had their blue shirts on there, running around with microphones, would have made it easy on me. I'm not heckling them at all.
Hey, I have a question. So earlier I saw in your YAML files that you had some grcr.io, so you have GitHub container registry. Are you impersonating the host, or when you create the local registry, when you create the archive, right? So how does it work? Because you basically download the container, and if your YAML file still points to ghcr.io, are you basically doing a host impersonation?
Yeah, excellent question. So the question is like, hey, my internet was cut off, my image pointed to GHCR originally, that is what's actually in the manifest here, is it's like in the manifest that's deployed, it points to GHCR. Why did this work? It's because we push that image up to our Zarf registry, and then the Zarf agent, this pod in the cluster, is a mutating webhook. And that mutating webhook changes the pods in the actual cluster so that their definition points to that Zarf registry. So if we look here, you can see that the image is pointing to 1.27.3199/zarfdev/doomgame. So that image got pushed to our registry. And if I look at my services in Zarf, we see that the Zarf Docker registry is a node port service on 31999.
All right, we got time for one more question. Anybody else? Okay, I'm going to take the one more question then. Oh, now you're going to take it over.
Thank you. And there's support for customization, like if I'm not using Git, use GitLab, or if I'm not using Docker registry, I want to use Nexus or hardware.
Yeah, so the question is, can I use a different registry if I already have one? And the answer is absolutely. So that Zarf init I did, by default, it's going to spin up the Zarf registry, but it has some flags here, like registry pull password, registry URL, and if you use that, then instead of mutating the images to use the Zarf registry, it won't spin up the Zarf registry, and it'll mutate your image to use, it'll mutate the images to use pods, to use your Nexus in the air gap, or whichever registry you pointed it to.
All right, let's give him another round of applause here for Austin.
And I brought a bunch of t-shirts and stickers. If anyone wants a t-shirt or sticker or wants to talk about air gap stuff, I'll come bring it to y'all.
The kids will love it. All right.